Hi, hello friends, welcome to our channel Study of Mathematics. Next, we will go to another problem in the solved problems 3.2.13 solved problems. Problem number 3. The problem is if a equal to I 0 0 minus I, then show that a square equal to minus I. This is our given problem. In this problem, we have to given the matrix A of order 2 by 2. Then we have to show A square equal to minus I. Already we know I is a identity matrix of order 2. Then I is 1 0 0 1. Then in this problem, we have to show A square equal to minus I. That means the square of the matrix A is equal to the negative of the identity matrices. Next, we go to solution. In this solution, first write down the given data. For that, given matrix is A equal to I 0 0 minus I. Further, next find A square. A square equal to A into A, that is matrix A is I 0 0 minus I into I 0 0 minus A multiplication. That is equal to multiply these two matrices. For that procedure is this row and this column. I into I square plus 0 0 minus 0 0 minus 0 0 plus I square, that is equal to I square plus 0 I square 0 0 I square. We know I square equal to minus 1. మీకు ఆల్రెడీ తెలుసు I square value minus 1 కి ఈక్వల్ అవుతుంది. That is here A square equal to I square is minus 1 0 0 minus 1. That is equal to, here we common the minus ni common తీస్తే minus of 1 0 0 1. That is equal to minus this matrix is equal to identity matrix I. That is therefore A square equal to I. This is the solution of problem number 3. Next, we will go to next problem in the same solved problems 3.2.13. The problem number 4. Next, problem number 4 is if A equal to cos theta sin theta minus sin theta cos theta, then show that for all positive integers n, A power n equal to cos theta sin theta minus sin theta cos n theta. This is our given problem. In this problem, we have to prove this A power n value is true for all the positive integers. For this problem proving, we have to use by using the principle of mathematical induction. Principle of mathematical induction is a topic is also discussed in previous classes. By using that, first given matrix is A equal to cos theta sin theta minus sin theta cos theta. This is the given matrix A. We have to prove a power n value. For that, by using the mathematical induction, first we have to consider the statement. First we solve this problem by using the principle of mathematical induction. By the principle of mathematical induction. For that, we have to call the statement, that is, consider the statement P of n is a power n is equal to cos n theta sin n theta minus sin n theta cos n theta. This is the a power n value. By using the mathematical induction, first we have to prove this P of n is true for n equal to 1, and also let P of n is true for n equal to k terms, and then by using this we have to prove P of n is true for n equal to k plus 1 terms. Then automatically P of n is true. The given statement P of n, a power n equal to cos n theta sin n theta minus sin n theta cos n theta value is true for all positive integers of n. This is the procedure. For that, first P of n is a power n if first n equal to 1, then P of 1 equal to P of 1 such that a power 1, that is cos 1 into theta theta sin 1 into theta theta minus sin theta cos theta, that is matrix A equal to cos theta sin theta minus sin theta cos theta. This is the matrix. P of n is true for n equal to 1, because we are already given A matrix is same, and substitute n equal to 1 in this a power n matrix. We have to also solve the same matrix. Then P of n is true for n equal to 1. Next, let us assume that the statement P of n is true for n equal to k, where k is the less than or equal to 1. K value is less than or equal to 1. That is, if P of n is true for n equal to k, then P of k value is P of k such that a power k value, substitute n with k, n బదులు k ని సబ్స్టిట్యూట్ చేస్తాం. అప్పుడు a power k matrix is cos k theta sin k theta minus sin k theta cos k theta. This is our assumption. Next, in the procedure, for the procedure, we have to show P of n is true for n equal to k plus 1. Then for that, consider p of k plus 1 such that a power k plus 1 that equal to a power k plus 1 value is equal to a power k into a power 1, that is a power k plus 1 equal to a power k value is cos k theta sin k theta minus sin k theta cos k theta into a power 1 is nothing but matrix A. Matrix A is cos theta sin theta minus sin theta cos theta, that is equal to, we have to multiply these two matrices, that is cos theta into cos k theta cos k theta into cos theta plus into minus sin k theta into sin theta cos k theta into sin theta plus sin k theta into cos theta. Next, minus sin k theta into cos theta minus cos k theta into sin theta. Next, minus sin k theta sin theta plus cos k theta cos theta. This is multiplication value. Cos k theta into cos theta minus sin k theta into sin theta. This is the formula of the cos A plus B. Cos A cos B minus sin A sin B. That formula value is cos A plus B. And here cos A sin B plus sin A cos B. This is the formula for sin A plus B. Here we use the formulas or cos of A plus B equal to cos A cos B minus sin A sin B. And similarly, sin of A plus B formulas are equal to sin A cos B plus cos A sin B. By using these two formulas, the above step becomes cos of k theta plus theta sin of k theta plus theta minus sin of k theta plus theta cos of k theta plus theta. That is equal to, this can be written as cos of, here take theta as common, then k plus 1 into theta sin of k plus 1 into theta minus sin of k plus 1 into theta cos of k plus 1 into theta. This is as similar with compare P of n. P of n value is cos n theta sin n theta minus sin n theta cos n theta. If n equal to k plus 1, the matrix is same this. Then therefore, by using this, therefore the statement P of n is true for n equal to k plus 1. For n equal to k plus 1. Hence by mathematical induction, P of n is true for all positive integral values of n. Integral values of n. This is the solution of the fourth problem. Thanks for watching our video. For more videos, please like, share, subscribe to our channel and hit the bell icon.